Thank you. All right. Thank you so much. Hi. Thank you. Thank you. Thank you. Thank you. Okay, so hi, I'm Aubrey Baker. I attend Lakeland High School, and next year I will be attending the University of Texas at Austin, studying engineering.
Hi, I'm Sarah Tipoff. I go to Centennial High School, and next year I'll be studying engineering at Texas A&M University.
So today we have an alarm device which will remind a parent whether or not their child is left in the backseat of the car. Now this device will prevent vehicular heat stroke from occurring in infants through a series of lights and sounds whenever the parent is leaving and the baby is bundled in the backseat.
Since 1998, there have been over 700 documented child deaths due to vehicular heat stroke. Now 54% of these deaths were caused because the parent forgot their child in the car. Not many people are aware of the drastic temperature changes that can occur in a car in just minutes. And so in the United States, Texas ranks #1 in the amount of hot car deaths of children.
As Sarah has previously mentioned, there have been about 700 documented deaths since 1998. Now, 54% of these are due to the child being forgotten in the car. The issue becomes present whenever parents do not realize how fast a car can heat up in a matter of very short time. In fact, the inside of a car can raise 20 degrees above its original starting temperature in a matter of 10 minutes. Now, you may be thinking, wow, it must be really hot outside for that to happen. Well, actually, vehicular heat stroke can occur in as low as 57 degrees Fahrenheit.
Some signs of heat stroke include nausea, dizziness, red and hot, dry skin, and actually a child's body can heat up 3 to 5 times faster than an adult's. And in fact, what many people don't know is that the windows being rolled down in a car and that even the AC running still enables a child to have vehicular heat stroke. So just because the windows are rolled down doesn't mean that the children won't require that.
So looking at our target market, we wanted to really focus on the parents and families with infants and that have automobiles. The automotive industry had a $82.8 billion investment in the year of 2017. Now in 2025, it is projected that that investment will rise to $169.46 billion. Much like the automotive industry, there will be an increase in number of children within the U.S. So in 2017, there were 9 million kids ages from 0 to 4, and as that number keeps growing, families are just going to be buying more and more cars, which just means that those kids are going to be even more susceptible to enduring that vehicular heat stroke.
A couple months ago, we sent out a consumer survey targeting the parents of small children, and in total we got 172 responses, and we sent it to about 8 preschools and Montessori's. One of the questions that we asked was what features they really wanted to have in a solution, and the most popular choices were that it's easy to install and that it's easy to operate. We really implemented this into our solution because it's self-reliant and it doesn't rely on the type of car or the type of car seat.
Another important question that we asked our surveyors was how they would like to be reminded or alarmed in case of an emergency. So we found that the majority of them would like to be notified through their phone or through an alarm on the key fob. Now through further research and investigation, we found that both of these ideas were inadequate.
Another question that we asked was how much people were willing to pay for a solution. Now the majority of people chose between $50 to $100, and this is still a large investment. But it's also important to note that about 25% of people would pay up to $200. This just shows how much people are willing to invest to create a solution to protect their child.
The total cost of our final prototype ended up being $101.79. Now you may be thinking, wow, that's actually pretty expensive. Well, this just takes into account the bulk items that we bought. So we ended up buying 100 small LED light bulbs, but we only used 1. So when you take that price down to the unit price, it ends up being $39.68. This is a very competitive price, and from the previous question that Sarah had just addressed, parents are willing to pay up to $200. When we put it on the market, we would like to sell it at $55 just to compensate for that amount of money we've spent on our bulk items as well as make ourselves a profit.
So going into some similar products, we researched the top 4 main competitive products on the market. One of our first products was the Cars for Kids safety app. This app is free, but it's only available on Google Play, so a large percentage of smartphone users will not be able to use this on their phone.
This is the Childminder soft clip, and it's going to be your most popular item on the market today. This one comes to be $39.95. However, this is very faulty as the parent will be alarmed whenever they're 15 feet away from the car seat. So that just means you're walking 15 feet away from the baby and then you have to walk 15 feet back to get the child who's already starting to heat up. So that's just another time delay that the baby is experiencing.
Next, we have the Even Flow car seat. Now, this does range up to $230, and you're paying for the entire car seat plus the Remind system inside of it. So, like we mentioned earlier, we wanted our solution to be versatile with any type of car seat, regardless of what it is.
Now, this is the 2018 GMC Acadia at a staggering $33,000. This is an astronomical price for the alarm system. However, you're not just buying the alarm system, you're buying the entire car. So if you're willing to go out and buy another car, then by all means, but for most people this is not very convenient. And there's other devices such as ours that are out there and you can just put into any car that you have.
Our overall product objective is to prevent deaths from happening to small children due to vehicular heat stroke. And some of the consumer benefits are that the parent and guardian won't be convicted of a felony. In fact, in the states of California, Florida, Georgia, and Arizona, this law is put into practice. Also, the child will remain healthy and not endure heat stroke. Also, this is a very easy to operate solution, so people can easily access the technology, and it's very versatile within its situation.
Now, we are going to talk about our final prototype and our projected solution. So originally, we wanted these two devices to be wirelessly communicated through each other. These two devices, one will be put inside of the driver's side pocket on the door, and the other device is in the back seat with the child on their seatbelt. However, as time came and we started creating this, we realized that it had to be hardwired. So we have one device with all of the stuff encompassed in it, and it is programmed through an Arduino Uno, and the Arduino Uno will send messages to the piezo buzzer and the LED light to emanate the sounds for 3 iterations, as well as the light flashing whenever the driver's side car door is open and the baby is buckled in.
Just click close and then again.
Maybe close the program.
Yeah, close it. It won't. Don't wait, never. And I'll click cancel. Yeah.
Here is the majority of our materials that were used in our final prototype. Here you actually see a t-shirt that was used. We used it in our 3D encasing to elevate all of the hardware within the box. This just allowed for the hardware to not be moved around as much and less chance of tampering with. We also use this 9-volt battery connector just so that it's very convenient for the user so that you don't have to plug it into an outlet because many cars do not have that kind of outlet. We also use a piezo buzzer, as I mentioned before. It emanates a very high-pitched sound that will not confuse or distract the driver. It will alarm them right away, and the parent will know that that is the alarm system. Here we have the reed switch. This reed switch is a magnetic sensor. We really wanted to incorporate the technology used in a welcome light that is used on some cars today. A welcome light will project the car brand name on the floor whenever the door is open. So with that same technology, whenever our car door is open, the alarm will go off as long as the baby is buckled in. should we close the program?
Yeah.
Just go ahead.
Okay.
We're very sorry for the technical.
No, it's okay. It's okay.
This is real world stuff. This is.
Or you get Microsoft Windows will update in 15 minutes. That explains
In the
everything.
middle of it.
Okay, so up next we have a video of our final assembly on Fusion 360.
Oh, oh my gosh.
Yeah. You probably don't want the full screen. I think that's what's causing the most problem.
Okay, so we don't have to present a full screen, we can just
Yes.
scroll through the presentation.
Yeah.
Oh, it's frozen.
Okay. Oh no. As you can see, that was an exploded view of our 3D model. You can see all the small pieces that go into the encasing.
Can you play it again?
Yeah, of course. There was this the LED, and then the breadboard and Arduino are parallel to each other. Should I present?
Yeah.
Okay. Okay, so this is an exploded view of our 3D model. The thing is, we only got our Arduino Uno from a pre-made source, but everything else we created from scratch on Fusion 360. We did create this encasing right here to be 3D printed in our classroom, and all the pieces inside here are in the model right here. Next, actually we're gonna do a demonstration of our product for you. So this is the encasing that goes into the pocket of the driver's car door. This magnet is on the door frame of the driver's seat, and this magnetic sensor is on the door. So whenever this is closed, it means that the door is closed, and when it's open, it means that the driver has opened the car door. Now, Aubrey is going to buckle the car, and once this opens, the alarm will go off. And as you can see, the LED is going off right now. But then once Aubrey unbuckles it, and the parent gets a child from the car, then the whole entire system will turn off. And as you can see, now that Aubrey has unbuckled it, the car alarm will not go off because it did not sense that the child is buckled. So this is a video of our product in a car setting.
Oh no, my baby! So, coming back to full circle with our final prototype, we just really want to emphasize the fact that this is solely run on that 9-volt battery. It is also programmed with that Arduino Uno, and that Arduino will sense whether or not the magnetic sensors are activated or not. And these magnetic sensors are very accurate, as the only thing that can set them off is the magnetic field itself. Another thing to keep in mind with our prototype is that it's very versatile with many cars. As long as that side pocket is on the front side door, then it will be able to be used within the car.
In the future, we would like to make modifications to improve the quality of our product. Originally, we intended for both devices to be wireless. We did try with the transceivers with the Arduino program, but the programming wasn't responding, so we did hardwire it so the prototype would work and function the way that we wanted to. In addition, we would like to make a more versatile casing because not all cars have a side pocket, and our device may not fit in all pockets of the side of the car. So we would like to make this available for every type of car, and just a more noticeable LED light because we do only have one and it's visible at night, but we would like it to be visible to everyone during the day, so it's an extra reminder to people. And we also ask that you please fund our project so that we can implement these future modifications to make this a really competitive product on the market and ultimately save the lives of many children.
And we just want want to say thank you to our mentor, Mr. Clayton Barnard. He's helped us really organize and develop these ideas, especially with the hardware, as well as Ms. Tungett. Thank you for your feedback and your critiques on a lot of our presentations and research. And thank you to our parents for the funding, the trips to Lowe's to get our materials and stuff like that. And thank you for the support throughout these past 6 months. It's really paid off. And thank you for your time. Question?
I'm gonna go first, Lucian, if that's okay. I'm gonna take your, giving you credit here. You had a slide where you had the exploded view,
Yes.
and you had 2 buzzard labels when one should have been LED. Top left, piezo buzzer, top right, piezo buzzer.
Yes, sir. I don't know how we missed that. But thank you for pointing that out.
I was just giving Lucian credit on that one there.
You see, you learned something.
I learned some details, right? So my next question, how long would a 9-volt battery approximately last before you have to replace it?
Well, the 9-volt battery for this model, it lasts about a month,
Okay.
only because the Arduino Uno just takes up so much power, so it
Sure.
drains the
And
battery.
it's constantly on, even though it's not going off.
Yes,
Right. So
yes,
that'd be a design consideration to think about longevity of batteries.
yes.
I have to say that I'm gonna use those 9-volt batteries, so I'm gonna stop. The last thing I have is, it appears as though when you exit the vehicle, that's gonna go off, right? So it's like a 9-year-old and 7-year-old now, but I had young children a while back. And, you have to get out of the car every time to unbuckle your child. So, having options on how it would go off, because you're not necessarily forgetting when you exit the vehicle, so I don't necessarily want it to go off every time I exit the vehicle. But as it's currently set up, it would, until I get in there and unbuckle.
Yes, that's why we program it, so as soon as that buckle is clicked, then every single time you would open the car door, it would only go off, but it's supposed to go off for only 3 iterations, and then it'll turn off. So if you just buckle the child and you get into drive, then yes, it will go off, but I think what we really wanted the focus to be is that getting out of the car. We didn't exactly know, like, we couldn't tell how a parent, when they were getting in the car and then whenever they were getting out of the car.
You would understand, it's not so much the getting in, it's the getting out part. So let's say for me, I don't want to necessarily every time I get out of my vehicle hear the alarm go off. So what that would mean is in order for me to not have the alarm go off is while I'm sitting in my seat, I have to turn around, unbuckle, and then exit my vehicle, and then get my child out of the car seat. And so I would just put some more thought into, is there a way, and I don't have that answer, on options on how the alarm would go off.
For that you've got like an on-off button or a volume button, because the potential issue I could see is what if your baby's asleep and you don't want to wake him up?
Big time.
So,
Yeah, I'm sorry,
Go
I
ahead.
interrupted. The previous solutions on the market, there was a time delay, and we really just wanted to try and eliminate any of that time delay, so that the baby just did not have that chance of getting heated up.
Yeah.
I understand, totally get that. I think
Yeah.
you achieved that very well.
Thank you.
Those are some of the concerns that I have. If I'm thinking from a perspective, as a prospective buyer. Okay, so if I'm looking at my options, this one gives me the opportunity to not have the alarm go off. How do you have your product give me that opportunity?
How hard is it to modify the connection so it trips the sensor? So, your magnetic sensors for the clips, how hard is that to install?
It's not hard at all. All you would have to do is make sure that whenever you put this box inside of your side door pocket, that this reed switch will connect with this magnet.
Okay.
Because the magnet just goes on the door frame, so it's stationary.
And I'm sorry, for the child seat, so if you unbuckle it, how did that transmit?
Can you explain how that works?
Yeah, explain how that works.
Yeah, so all we did was we weaved the wires in between the existing buckles so that the magnetic sensor is right here. And this is on the back of the car seat. And so once this is clicked, the magnet will be attached to the magnetic sensor, and then that activates the side system. So like whenever this is unbuckled, this will not take into effect.
So you're gonna have to modify, when installing this, you're gonna have to modify that connection to be able to output that information.
Yes.
No, look at it.
so you're going to modify the car seat itself. So, two questions. One, how secure is it? Will a child be able to mess with the magnet or get it loose in any way? And then the second one is, what do you do if you have to take the car seat out of the car?
Well, just to answer your second question first, all the parent would have to do is just take the magnetic sensor out and pull the wires out, and then they can leave the whole entire system in the car and then take the car seat with them. It was a pretty easy installation. All Aubrey did was just weave the wires, like just put it underneath. But like with the child messing with it, we did think about putting like an encasing around the magnetic sensor so that if the child tried to touch it, that it wouldn't happen. But we couldn't get it to stick onto the buckle, and just with that, like a lot of the times it is babies sleeping in cars. That's how people forget, and so we would think that if they would be sleeping, that they wouldn't try to get this.
That part which kind of attaches, so once you get back in the car and close the door, do you have to manually attach, or it's gonna kind of automatically get in place?
It should automatically get in place whenever you put this box in the position of the car. You can secure it to the door, and then it will be, this magnet will be stationary, and then the car door will close at the same place every single time.
Yeah, okay. Yeah, that was my main concern, if you have to do it, like, and also, I don't know, like, if you can somehow just, I don't know, just hit it with a leg or something, so detach, or you make sure that that cannot be detached when driving or something like that.
Yes.
Does that connection work when saturated with liquid all over it?
We actually did not want to test that because we probably thought that there would be an electric shock, but but yeah.
Did you test what the actual current was that's needed to make that connection?
No, we did not.
We just we did install the 9-volt battery because that was
how it was powered with the AC plug-in.
yes.
Yeah, and then also like, well, I have a little knowledge about batteries, but that battery will be in the car all the time, and if you leave the car in the parking lot, it can get very hot inside. So I don't know if that will drain the battery or damage the battery or cause some issue to the battery, but it's just something which might be an issue or idea how to solve it. Just think about that. And on the first slide, I'm gonna bother, first or the second slide, you were talking about mortality.
Yes, I know.
I know what you're talking about.
Yeah, so I think they're not moralities, but mortalities, so you're missing T.
I remember going in and fixing that word. That's why I volunteered. I remember going in and fixing that.
Not a big deal, just.
I have a question.
Yes.
When you guys were doing your research and your competition, did you ever run into a scenario where one of their devices failed and they got into legal trouble? Did you ever see that happening?
I think the main issue was that a lot of devices were reliant on Bluetooth, and so a lot of consumers wrote back like comments on the website that it was very malfunctioning, like it did not work, like the connection was always off. I haven't seen anything about legal trouble with certain products, just legal trouble with people forgetting their child in the car, and then the results of that consequence.
Yes.
I was just thinking, you know, if this or any of these products fail and it would result in a child's death, that's a lot of hot water for a potential company to deal with.
Yeah.
A less gruesome question. After you've installed this, are you gonna get tangled up in the wire if you're like getting groceries coming out of your back seat, or you know, like when it's installed, is it messy? Am I gonna trip over it, or what's that like?
Only on the drivers.
Okay, so with our future justifications, we want it to be wireless just so that there's not a wire traveling from the front side door to the back seat. And that's where the issue comes in with tripping. But other than that, you will not get entangled whenever you get the baby or anything like that.
So with this wireless fault, you currently at a $40 market price, what do you see your part request be with these improvements?
So we actually tried the transmitter and receiver, but the coding just was not cooperating, and with the time we were allotted, it just couldn't come to fruition, basically. The transmitters and receivers themselves were about $10 total, like together, so it's not much of a price increase.
Can I ask you a question on the actual design?
Yes.
Did you look into using a Raspberry motherboard over an Arduino?
We actually
That
did
was
start out with a
very
Raspberry
perfect.
Zero. We did start out with a Raspberry Pi Zero and got all the programming up and working, and then we're halfway through, we're like, we're switching to Arduino because it was just easier for coding.
Sure.
And
Yes.
we felt, and it was a lot more versatile with the different functions that it can perform versus the Raspberry Pi Zero.
And whenever we tried to make this wireless, we would have to have two separate devices. So we would have to have a device here with the seatbelt and then the device within the car. We originally had an Arduino Nano in here, but since the transmitter receiver just was not cooperating, we decided to hardwire and simply use the Uno.
Got it.
Thank you.